Okay, good afternoon and welcome to the 7th session of the Spring 2020 Sunoikisis Digital Classics semester. This week we're talking about text and translation alignment with Chiara Palladino from Furman University and Tariq Yousef from the University of Leipzig. And we're also joined by Dimitar Iliev from the University of Sofia there. So, hi everyone. And I believe Chiara will be starting us off with an introduction to the topic, so I will hand over to her.
Yeah, thank you. Thank you so much, Gabriel. So I hope that everybody can see my presentation. Welcome to this session of Sunoikisis Digital Classics. As you probably know at this point, we are going to be talking about text alignment. My name is Chiara Palladino, and I work as Assistant Professor of Classics at Furman University. And I will be holding this presentation together with Tariq from the University of Leipzig. So we're just going to give you a short introduction about this session first, and then I'm going to guide you through a live demo of the tool that we use for performing text alignment in digital environments. So I'm going to talk about what is text alignment first, and to set up a couple of fundamental concepts that we're going to use throughout the session. I'm going to show you how to use our tool, which is called Ugarit. And then I'm going to talk about how we use Ugarit in a couple of sessions in the classroom to teach and to deal with a variety of languages, more specifically with pre-modern languages. And then Tariq is going to talk about possible advanced applications of the data collected through translation alignment, including automatic translation alignment, graph databases, and the use of a dynamic lexicon. And then at the end of the session, we're going to introduce two options for the exercise that you can do after the session. One is low stakes, a simple exercise of translation alignment, and one is high stakes. So first of all, what is translation alignment? We generally define text alignment as the comparison of two or more texts. So this is a general notion. We talk about text alignment when we align texts regardless of what their language is, whether they are in the same language or whether they are not in the same language. And the general purpose of aligning texts is always the same. We try to define similarities or divergences in texts, or to find relationships between texts, whether they are in different languages or in the same language. And in computer science, text alignment is extremely important. It is, in fact, one of the most important tasks in natural language processing, because there are methods to perform it automatically, both between texts in the same language and in texts with different languages. Another concept that I would like to lay down at this point is that alignment is not necessarily just word alignment. In fact, we usually perform alignment at different levels, starting from the macro level of the document, so we can align different documents, and then proceeding up to the smaller level, so we can have paragraph level alignment, sentence level alignment, and finally, word level alignment. We talk about different types of alignment depending on how many texts we align and what we align specifically, if we are aligning text in the same language or not. One of the most general definitions that we use is pairwise alignment, when we align two texts in the same language in most cases. And in general, we talk about pairwise because it shows two texts. And obviously, the purpose of this kind of alignment is to detect the differences according to specific alignment algorithms, or just manually aligning two texts. We talk about multiple alignment if we're talking about the alignment of multiple texts, as you can imagine, so more than two. And virtually, we can align an unlimited number of texts. In an ideal world, you should be able to align as many texts as you want, but obviously, especially if we are in computer-based environments, in automatic methods, it is very difficult to align a potentially endless number of texts because of the very many variables that at that point can interfere with the good performance of the alignment method. And finally, we talk about cross-language alignment when we talk about the alignment of texts specifically in different languages, so two or more languages. And this is one of the most difficult computational tasks to perform automatically because essentially, in order to perform a good automatic cross-language alignment, we need training data. In other words, we need manually aligned word pairs and bilingual dictionaries. So typically we perform, in automatic methods, we perform word alignment after a higher level alignment has already been completed. So we go from document to sentence and then from sentence to from sentence to word. And as I mentioned, we need to have some training data in order to have a machine that actually understands how to use algorithms to appropriately align words. And the reason why it is so difficult is because, as you can probably imagine, texts are not perfectly translated across languages. Translators do not always translate one sentence exactly in the other language. And there are also implicit cultural and linguistic differences that condition the perfect matching most of the time. And then finally, obviously, there are problems which affect the machine methods more specifically, which is crossing dependencies. So when the order of the words in a sentence is changed across languages, depending on what language you're using, obviously languages have different word order to make sense. We generally use translation alignment or cross-language alignment with parallel text. What is a parallel text? A parallel text is essentially a text that is placed alongside a translation or multiple translations. And generally, we talk about parallel corpora when we talk about large collections of parallel texts in multiple languages with multiple translations. And in this case, we talk specifically about translation alignment because we are in the domain of translated texts. And translated text and parallel corpora in general are like all over the place. You know, one of the largest parallel corpora existing is the Bible corpus, which contains about 1,000 unique translations, but also there are websites with, you know, multiple translations of famous poems or literary works. Subtitles are a perfect example of a parallel corpus with multiple translations of the same thing, and so on. So we can use translation alignment to establish correspondences between parallel corpora, between parallel texts, and to better understand the differences and similarities across those. Now, the tool that we use to perform translation alignment is a tool called Ugarit. And Ugarit is a translation alignment editor, which is used to perform manual cross-language alignment. In other words, you can upload your little texts and you can perform cross-language alignment manually in the digital environment provided by this tool. So originally, Ugarit was a sort of a crowdsourcing project in a way. We designed Ugarit in order to generate training data sets in order to provide, again, training data for automatic systems of text alignment. But over the course of these few years, we started in 2017, Ugarit has also been used for a variety of other purposes. It has been used as a reading environment for, you know, interactively read texts alongside their translations, and as a learning tool. And we're going to talk about that in a second as well. And there are also multiple applications that can be developed from the aligned word pairs that do not have necessarily anything to do with automatic translation as well. So we started, as I said, in March 2017. We are in February 2020, and we've had a good number of unique visitors and a good number of recurrent visits since when we started. Ugarit is currently used by a variety of different users. So now I'm going to switch my screen and I'm going to go for a live demo of the tool. We decided that it would have been better for you to have a good look at how Ugarit is actually used and a guided tour of the tool itself. So this is the homepage of Ugarit. And as you can see, what the immediate visual impression is that of a graph of connected languages. At the very center, the bigger bubbles, so to speak, are the languages that are mostly used inside the tool, and these are the languages that have the most language pairs. You can have a breakdown of the number of texts, the number of languages, translation pairs, and users that we currently have. And we have a section with the newest alignments that have been created most recently, a list of users up here. And down here, there is a full list of language pairs, including specific numbers for the number of paragraphs present in the tool and the pairs that are currently present. It's a very long list, as you can see. Our users range from scholars to students to beginners in the study of a specific language to teachers that are using this tool within their classroom. I'm just going through the list of the current users, which is, as you can see, extremely long. So in order to use Ugarit to perform translation alignment, you either have to create a new account or you want to log in with a pre-existing account. And once you log in, this is what you're going to see. You're going to see what you have, what types of alignments you have already performed, and you can usefully have text groups or folders, essentially, within which you can group specific alignments, specific sections of text that you have alignment for a specific project. And you can also have favorites up here. These are alignments that other people have performed that you can save, so to speak, within your own profile, within your own dashboard. So if you want to perform a new alignment, you can choose between, as we mentioned, pairwise alignment, so you can align 2 texts, or you can decide to align 3 texts in 3 languages. If you click on any of these windows, it's going to open pretty much the same view. And what you want to do is essentially to select the languages that you want to translate according to a list that we have. And if you want to align a different language, just let us know, because we can add that to the list. So for example, we can choose English and Latin, and I'm going to open up one of the text files that we have included for you if you want to go through the exercise. And I'm just going to copy paste the first line. This is the Bible corpus, as you may have understood. And then you just want to click on Align. So this is the edit view. What you want to do is to add a couple of things in order to have this appropriately saved. So you want to have a name for a translator if you have it. You want to have some kind of title for your alignment. So we're just going to put Genesis in here. And you can decide whether you want to make your alignment visible or not. If you click on no, that means that nobody's going to be able to see the alignment. And you can change the languages at all times.
Chiara, would it be possible to zoom in just a little bit?
Yes, absolutely.
Thank you.
How does this look? Is it good?
Great.
Great. So what you want to do now is essentially just to click on the individual words or tokens and have them aligned. You can just align word by word, for example. And once you have the 2 tokens clicked on, it's going to automatically save them. But you can also manually save them by clicking on this little button here. And as you can see, the aligned pair appears in this column on the right. But you can also align multiple words. Like, for example, I can align the beginning, so the article together with the word, with the Latin principio, which doesn't include an article. And once you're done, you want to save it to database. And it's going to appear in your dashboard. You can also explore what other people have been doing in terms of translation alignment. And for example, if you click on a user and you want to explore what alignments that user has made, has completed, you can easily have access to what they've been doing, to the activities that they've been doing. And you can explore, just passively read, so to speak, the translated text, the aligned text that this user has been doing. So you notice that if I hover with my mouse on specific aligned tokens, it's going to show what is the corresponding alignment across the languages. And another very interesting feature is that Ugarit also provides transliteration of non-Latin scripts. So you can actually see how that specific non-Latin script can be pronounced. And this feature is currently available for the majority of the non-Latin scripts that we have within the database. And you can see that aligned tokens are usually displayed in blue in pairwise alignments, and red tokens are the tokens that have not been aligned. This little bar down here is essentially showing the percentage of aligned tokens versus non-aligned tokens. The former ones are in green and the latter in red. Tariq is going to talk more about this, but essentially most of the aligned pairs that you create by working in Ugarit go into a thing that is called a dynamic lexicon. Essentially, they create training data for improving currently the current automatic alignment methods that we have. And a little showcase of this is the search bar. So you want to look at some word and see how many aligned pairs are available in Ugarit for that word. So I'm going to type on life, for example. It's going to show me the whole varieties of this word as we have in the tool. I can click on life in English. And what's going to show me is all of the available translation pairs of this specific word as they are available in the database. It gives me a frequency number. It gives me a variety of options depending on what words have been matched with this English word life. As you can see, Greek is on top of the list, but there are also other languages. And I can also visualize this in the form of a graph. Down here, which is actually my favorite feature, is the analytical view of all the texts that have that word and their corresponding translation. And if you click on one of these words, it's also going to open up a sort of a prettier representation of the graph, where you can have a global view of all the corresponding translations and a general idea of which language is prominent in that. So this is pretty much it. As I mentioned, you can either create your own profile and play around with Ugarit and perform your own translation alignments, or you can just have a look at what other people have been doing and read their texts interactively and have a look at how they have performed translation alignment. What we have been doing in this regard is use translation alignment and Ugarit to teach a variety of ancient languages. And there is a couple of, I'm going to scroll down to these slides that I prepared just in case the demo went horribly wrong, and I'm going to go to the case studies. Case studies are essentially a couple of examples of how we've been using translation alignment for the study of pre-modern languages. And these are by no means the only options that you have if you want to use translation alignment in the classroom or as a student of a language. So some of the potential options to study a language through translation alignment are listed here. Translation alignment is a very good analytical method to compare and contrast how specific words and specific concepts are expressed across languages. Because it is systematic, it forces you to enter in a dialogue with the source and try to understand how that specific cultural concept finds a correspondence or doesn't find a correspondence in available translations. And this is particularly useful when we are dealing with completely different historical, chronological, or cultural contexts. So we have found that translation alignment is particularly useful to develop the sort of knowledge, the sort of in-depth knowledge of the cultural concepts expressed in a source language. To a certain extent, it also helps somebody to become a better translator by contrasting different translation strategies. What you can do with translation alignment is essentially to analytically compare different professional translations of the same ancient text. It doesn't even have to be an ancient text. It can be a literary text in general. One very interesting outcome that we have noticed in students is that sometimes they can use the skills in a third language as a bridge to convey similar constructs and similar morphological constructs across two different languages. And this has been particularly fascinating to see in students that had a good knowledge of another modern language, for example. How do they use that alongside English to better understand a language that they were not proficient in? And then finally, you can use translation alignment to read a source language that you're not familiar with, maybe even just completely unfamiliar. You can use that either as a passive reading aid to just, explore already performed translation alignments, or to try to test your own competence and try to approach a source language alongside one or two translations in languages that you know. So, for example, the student of mine created this very, very long translation alignment of Plato's Symposium by performing pairwise alignment against one of the very famous translations by Nehamas and Woodruff, within the context of a research project that integrated also tree banking. For example, for those of you who do not know tree banking, there are 2 sessions in Sunoikisis Digital Classics this semester that focus on tree banking and its applications. And the aim of this project was essentially to provide consistent aligned text against English so that other readers could explore the text. For this reason, this student in particular developed a consistent alignment strategy in order to make sure that aligned tokens would only be corresponding to the Greek, in this case, in meaning and grammatical function, with a couple of partial exceptions that were inevitable. This other student was approaching a very complex and skillful literary work, The Metamorphosis by Apuleius, and his task was actually to compare 2 different translations and then to perform his own translation of the text. Because this is a particularly skillful literary work and rhetorically skillful literary work, he decided to compare specifically expressions with potential ambiguities and compare different translation strategies according to which the translator decided to approach particularly difficult cases. And you can see that the alignment rate is not particularly high. There are a lot of red tokens here. One of the other very interesting things was when we had students of a third language. For example, the student was a student of German, and he tested an alignment of a Latin text, Tacitus's Germania, against English and German. He found that actually German had a better alignment rate than English, probably because they're both inflected languages. And this is the case of a student who was trying to align a Chinese version of the Ajax. And the Chinese version was, in this case, based on the English, and so obviously displayed a higher matching rate with the English rather than the Greek. But because the student in particular knew Chinese very well, she was able to match and use the knowledge of English and Chinese in order to approach a text that was not that familiar, and it was also particularly difficult. One of the most interesting cases, though, was to test translation alignment on students that had no prior knowledge of the source language and that had never seen a Greek text, for example, in their lives. For this type of exercise, we do recommend to have some sort of guiding strategies and some sort of guiding tasks that the students can use. So we gave them specific exercises to perform at first. One of the most interesting exercises is to pair single words as they are found in the source text, of which we know the meaning, like holy, honor, love, and align them with the corresponding word in a translation or more translations. And what usually happens in this case is that translations do not provide the same translation of one specific word that has this cultural depth. And so this obviously triggers a conversation about why it is the case and what does that mean for the culture that originates that word and that concept. Then we extended this task to the comparison of specific expressions, which obviously opens up for a discussion about word order, for example. Obviously, the word order in an ancient language is not going to be the same in a modern translation, opening up the field to a discussion about morphosyntactic constructs across languages and translation strategies. How do translators approach a word order that is completely different and potentially very different syntax? And then finally, we had our students complete a bilingual or a trilingual alignment of a short passage, which obviously for students that have no prior knowledge of the source language entails intensive and systematic analysis of the linguistic and expressive content. But in general, the students were able to assess the linguistic differences between the languages and demonstrate that they could actually, in fact, approach a text in a language that they did not know by means of translation alignment. So for example, the student had a very good knowledge of Greek and English, but was not familiar with Latin at all. And you can see here that there are so many parts of the text that have not been aligned specifically for this reason, because he tried to focus on areas where he could use English and Latin to leverage his unfamiliarity with ancient Greek. But he was also able to identify specific common aspects, for example, in the morphology and in the inflection. This other student was a Chinese native speaker who used Chinese and English as means of comparison against a text in ancient Greek. This was the beginning of this was one of the sections of Bacchae of Euripides. And specifically, the student was particularly interested in investigating, again, crucial concepts and how they are expressed across languages. And having to do with two translations that are in languages that are so different, this resulted in an investigation about also comparative cultural concepts, and also in an emphasis on imperfect correspondences between grammatical and semantic expressions. Like, for example, Tosophon, which is usually cleverness, was translated in English as being clever. All right, so I'm going to leave the stage to Tariq now, and he's going to show us some applications, and then we're going to dig into the exercises, the high stakes and the low stakes option.
Okay, hello everybody. Now I will continue the presentation. I will be talking about the application and exercises. First, let me introduce the structure of our algorithm system. As you can see here at the user interface, we have the algorithm editor where scholars and students are able to align 2 texts or 3 texts. And then here we extract the aligned translation pairs and we save them in our database. But not only, as we mentioned, that this project is a crowdsourcing project, so we collect data from everywhere. For example, we have a big translation pair data set from GISA++, aligned by GISA++, provided by Perseus. We have also added some morphological tools like Morpheus for Latin and ancient Greek, and other tools for other languages. We have also some translation memory datasets added to the translation pairs repository. We have also some bilingual dictionaries, since we can extract some translation pairs from these dictionaries and save them to the repository. And at the back end, we provide the search function where users can search for specific word, token, or phrase in our database. And we also able to create dynamic lexicon. The idea of dynamic lexicon that some languages have very small amount of resources or common resources together. So the aim was to find bridge languages to create these translation pairs. For example, if we have a text in ancient Greek but we have no translation in Arabic or maybe in Persian or maybe in Chinese, so we try to use some bridge languages to find these translation pairs. For example, if we have text translated, ancient Greek text translated to English and English translated to Arabic or Persian, we can use, for example, here English as a bridge language. First, let me show you an example. Show you an example of the dynamic lexicon. It's available under dynamiclexicon.com. Here we have four languages: English, Latin, Greek, and Persian. So the English and Latin and Greek are clear. The data are extracted from the automatic aligned data by Giza++. As I said, it's available on Perseus. Giza++ is an software which can create automatic alignment using IBM models. It's a good one. It doesn't create 100% accurate alignment, but we can say 95% is okay. Let's try to look for something. For example, if I want to look for the word alive in English, as you can see here, I get the translation in different languages. I get the Greek translation and the Latin translation and the Persian translation. The Persian texts are aligned manually, so the accuracy of the alignment is very good. Here, for example, since life is translated to these three languages, we can say that this word Omar in Persian can be aligned to the Veta in Latin onto this word in Greek. Sorry, I cannot read the Greek alphabet. So if I want to translate, for example, love in English, here we can have ishq, amo. Also on here we can get the examples of this alignment, how we can find this alignment. For example, here love can connect all these translations together. So that was the idea behind dynamic lexicon. At the beginning, we were saving our data in MySQL database, which was not working very good with this structure, the alignment structure. So we thought we need to find a new structure. We suggested to use a graph database. So we represent every translation pair as two nodes connected by each called translation. For example, here we have this word God in English. Here we have this word in ancient Egypt. So I don't know the translation, but here we use the transliteration, and this word is translated to God. So as you can see here, we have these two nodes. These two nodes represent a translation pair, and in this edge we can save the frequency of this translation pair, how many times these two phrases occur together. If we extend the view, we can see this big graph. For example, the source of this graph is the word God. As you can see, God, how it's connected to other words in different languages. For example, here we have a goddess. Since we have English can be translated to Greek, and Greek also can be translated to English, so we can find so many English equivalent to God. For example, here a goddess of the goddess gods. Of course, we can do a lot with this data. We can filter the data, we can clean the data, we can use some kind of lemmatization to reduce the number of nodes. Here we can see some Persian words. Here, ilahi, we can see ancient Greek, we can see, Bulgarian, we can see, so many languages, German. Yeah, this kind of network that we can get if we use the graph database. I've been using a new 4J graph database, which is working very good with this structure. I can very easily run a query in very simple way, like here, match PA, which is give me the shortest path between the word city in English and the word civis in Latin. As you can see here, I started with city. I got the Greek translation, then maybe the English translation, because this is translated to this, and this also translated to this, and to these two citizens, and citizens are translated to civis. So this path I can get start from city and end with civis. That's with very simple query I can get all these data. To make this easier to use, we designed a front end to simplify the search function. Here, for example, if you look for the word city, you will get all these words we call translations cloud. So all these words are translations of city in different languages. As I said, we can run some filtering functions just to filter the results. For example, to get the results which have frequency more than 5 or 10 or something like that. And here, for example, if you click on the word DR in Persian, you got this translation. This is the path between this word and city. Here we have city in Greek, country, and country is translated to DR. Let me show you, this is here, if you can see, it's a bigger network. Yeah, here is city. Here you can find the languages over there. You have Greek, Latin, Persian. I guess this is Armenian, German, Italian, Portuguese, Bulgarian. I guess Spanish, Arabic, ancient Egypt, Georgian. I guess here. I don't know, Coptic. Yeah, it's very small word here, if you can see it. We have also Croatian. Let me try something with the word here, Shahar, for example. I have direct translation between city and Shahar. If I take this, I guess here we have city is translated to Greek, to Polish, and this translated to Armenian. So as you can see, if I don't have English Armenian dataset, I can create it using Greek as a bridge language. Yeah, as you can see here, German. Also, I can get the Stadt from city via Greek language. Here, place. As you can see here, we have longer path between them. Yeah, this is the kind of the visualization called translations cloud. And here, the translation of the word God. Here, as you can see, the same idea. Khuda. So this was the idea of dynamic lexicon. We can we build this network, and then we can extract the data set between any two languages that we want. The aim of this was just to create training data for the automatic alignment. As you know, text alignment is the first step of statistical machine translation, which is kind of translation generated on the basis of statistical models And the parameters are derived from the analysis of bilingual Corpora. For example, if I want to translate this text from Spanish to English, I need the kind of bilingual text, big text, Corpora aligned one, so I can extract the translation pairs. Then I can replace each word with corresponding translation in English. And here I need a kind of language model to convert this list of broken English of these tokens to a sentence, to a valid sentence. The language model is a basic component of any statistical machine translation system. It helps to make the translation as fluent as possible. As you can see here, we can we have some software which are already available online. As I mentioned, GISA++, which works very well. We have also Moses. We have the Cambridge Statistical Machine Translation System. We have also Stanford Phrasal, which use phrase-based translation system. We have also the neural machine translation, which is an application of deep learning in which massive data sets of translated sentences are used to train a model capable of translating between any two languages. As you can see here, we have we already know that we have Google Translator, we have DeepL. The idea, I give the source sentence and then I click a button and then I get the translation in the desired language. But how these work? And the first version of this NMT neural machine translation was the encoder-decoder structure. As you can see in the picture, this architecture is composed of two recurrent neural networks used together to create the translation model. Before we start, we need to convert this sentence into a mathematical representation using kind of word embedding, such as word2vec, one-hot vector, any kind of word embedding representation, because we cannot work with words, we need to deal with numbers. This is how deep learning or neural machine learning algorithms works. After we encode these sentences in this using word embedding, then the encoder portion of the model takes the sentence in the input language and creates a thought vector from this sentence. As you can see, we convert this sentence to a vector called thought vector. Then this thought vector stores the meaning of the sentence in numbers, and it's passed to decoder, which recreate or rebuild the sentence in the target language. So this is how neural machine translation systems work in very simple way. I don't want to go in details because it's very complex. Let's move to IBM models. IBM models are a sequence of complex models used in statistical machine translation to train a translation model and an alignment model. So we use these models to create a translation alignment between two texts. We have 5 models, starting from 1 to 5. The first one uses just the lexical translation, the word form, without looking to the position of these words. The model 2 takes into account the word position in the sentence. Model 3 use the one-to-many alignment using the fertility model. Then we have the model 4 and 5 adding new classes like part of speech and other semantic classes to the corpora. we don't really have time to explain all this model. I shortly will explain the first model, the simplest one. As I said, let's see that we have two sentences. The one in the foreign language, the French language. We have token F1, F2 until F and English sentence, and we try to find mapping between these tokens. So the idea, if I have already a dictionary or a list of probability that these words, for example, here I have sentence in German, das Haus ist klein. If I already have dictionaries or a translation table that tell me das can be translated to the, like 0.70% to that, to which, so I can pick like the most probable one. Here I can take house is small, but the idea, we don't have these tables. We have to create these tables. Since I start, it's a kind of unsupervised learning. I have only the text, and I have to create these tables, this probability distribution, and pick the best alignment. Let's start with this very simple example. We have here 3 sentences in French and in English. As you can see, I just count the frequency, how many times these two words occur together. For example, the word la and da in the first sentence. Here, the frequency of da is 1, and the frequency with la is 1. So they appear only one time together. And the same with house, la, house. Here we have 1, here, this table for the first sentence, and the same here for the second sentence, and here for the third sentence. Then I try to sum up the frequency, build a big table, which here we have all tokens in the English language, and here the token in the French language. So I collect like la, da, how many times they appear together. Here we have 1, 1, 1, so it's 3. La with house, here we have 1, and here we have 1, so it's 2. La with blue, it's here 1, I guess, yeah, and with the flower 1. So as you can see, that la comes with the 3 times, with house 2 times, and blue flower 1. Also the total here is 7. I repeat the process here for the same. We have maison with the and with the house. The sum is 5, 3, 2. Now I normalize these values by dividing every cell to the total here. As you can see, we have ones. Here we have 3 divided by 7, 2, 7. And then I reassign this probability to the tables. Here we have 3 sevens, 2 7, 2 fifth, 2 fifth, and exactly. I reassign these values to these tables and recalculate these values. So I repeat this process, which called expectation maximization. So every time I fill the table and refill it until I get a kind of coverage. For example, here we have la with that is 0.6, la with house is 0.4. And here, then the same process, I build a big table I have here. So as you can see, like la with that starts to be clear that they are aligned together. Here, the frequency is 0.6, 0.4. I repeat this process until I get the alignment here, the normalization. I repeat that here, for example, the probability that la is aligned to that is 0.72. Then I repeat until I get coverage. Here, for example, you can see at the end I can get la aligned to the and maison aligned to house and blue to blue and flower. So this model called IBM Model 1, which takes into account only the word form, doesn't account on the word position. We will see how we can do that with Python using NLTK and the high-stakes exercises. Yeah. Chiara, if you...
Right. So one is low stakes, and it doesn't require you to do a lot of programming, but just to think about how you can use translation alignment to better understand the text. And then the other one, which Tariq is going to illustrate, is the high stakes exercise if you want to put yourself on the test with a little bit of programming. So the low stakes exercise is very simple. Try to align a language that you do not know. You can either use a parallel corpus of your choice, if you have one, or use the corpus of the Bible that we have provided that you can find in the GitHub page for this session. And there's a link in the slides as well. You should choose, ideally, you should choose 2 languages or 1 language that you're familiar with and focus on the differences across translations. First, our recommendation is to try with only 2 languages that you know, so that you have a good sense of where the text goes and of the rate of alignment. And try to ask yourself the following questions. What words are aligning perfectly? What words are not aligning or aligning imperfectly? What is missing? What are the tokens that are just missing across the text? And what is the overall percentage that you can have of matching words or tokens? After you have completed the bilingual alignment, you should choose a text in a 3rd language that you do not know and perform a trilingual alignment against those 2 texts that you have already aligned. And see how much of the 3rd language you can align by using the 2 texts that you have already aligned that you know fairly well at this point as a bridge, as an aid for better understanding. And at this point, you should think about a variety of very interesting questions in terms of the differences that you can find with that 3rd language. And you can just see how much of that 3rd language you can understand in terms of individual words and in terms of syntactic constructs as well. I'm going to leave word to Tariq for the explanation of the high stakes exercise.
Okay, now, you can find the notebook on the Sunoikisis DC 2019-2020 repository here inside the slides. You will have the translation alignment. Here we have the notebook, Jupyter notebook, and also the data that we have. The data is available in 2 formats, text and XML. In the text folder, you can see the different translation of Bible. All of them have the same structure. Here, if we look, we have the verses ID and the text of the verses. Now, translation alignment using NLTK. NLTK provides us a storage class called alignment. It's used for representing the alignment between 2 sequences, S1 and S2. It's kind list or set of tuples. Here, as you can see, this is the structure of the alignment. It's a list of tuples. We have 0 to 0. That means the token, the first token, the 0 token, and the first sequence is aligned to the token 0 in the second sentence. 0 to 1, as you can see here we have kind of multiple alignment, many to 1. 0 is aligned to 0 and to 1. Here 1, 2. Yeah, if we run it, you can import the package from NLTK translate import alignment. Here we have the function invert, which reverse the alignment. So the source language will be the target, and the target will be the source. Here we can build an alignment object from string. We pass just string. Here you can see this format called GISA format. Here we have white space between these. We have here dash between these 2 indexes. The indexes should be integers, and between them there is a dash, and between every tuple we have a white space. We also have the aligned sentence class, which encapsulates two sentences along with an alignment between them. Here, as you can see, I have two sentences. Every sentence is split into tokens. Here we have Klein ist das Haus. In German, the house is small. And here I have the alignment. That here 0 is aligned to 3. 0 in the source language, always the source language is here. And the source language and the target language. A Klein, for example, here, which is 0, is aligned to small, 3. And 1 is to 2, which is here, is 2 to 0, das here, and 3 to 1, house. I can run this. Yeah, I can access the words in the target language via align sentence.words here. Here is the target language and the source language with mods. And here the alignment. I wrote a function to print the alignment called print alignment. I pass align sentence object, and then I get the alignment. I print the alignment. Okay, I have to run this first, and then this. Here it prints the target sentence and the source sentence, and here is the alignment between them. Okay. Also, NLTK provides a Comtrans corpus, which is a subset of the European Parliament corpus. This corpus is aligned at sentence level. We have the English-French, German-English, and German-French data. As you can see, I can import the corpus from here, from nltk.corpus import Comtrans. If I want to see the available files here, I have the alignment Deutsch-English, Deutsch-French, English, and French. So if I want to print how many aligned sentence in every file, I can run this code and get like the German English. We have about 33,000 words. They are the same. Yeah. About for each pair of languages, we have 33,000 aligned sentences. Here, if I want to access the word, I call the function words, and I pass the name of the file, which is English-French.txt. Here I get the first 20 words. If I want to get the first sentence, here I call the function align sentence, and I pass the name of the file, and 0, which is the index of the first sentence here, and I print words, so it's the target language. If I want to print the alignment here, as you can see, resumption of the session, please the last session, we have here session is aligned to session, resumption of, and the. Also, I have the function invert, which make the source sentence as target sentence and the target as source. If I run it here, I just inverted the align. IBM models. As I mentioned, we have 5 IBM models. Here we will introduce 2 of them, IBM 1 and IBM 2. As I said, all of these models use expectation maximization algorithm to create probability tables. Yeah. First of all, I have I have to create the parallel corpus, since I have the data in text format in different languages. I decided to use English and German, but feel free to use any pair of languages you wish you are familiar with. Here, I used tokenizer, regular expression tokenizer, just to split the text into tokens. Here, I read the data, open data text English. Yeah, I read the line. As you can see, the data are, we have two columns, they're split by tab. So I had to split this line into two elements, the text on the index. Here you can see I split it with /t, and I built a dictionary called English. The index, which will be Genesis 1:1, for example, and then I tokenized the text. If I run these, I will get so yeah, I have to create the tokenizer. Yeah. Just 1 second, please. Yeah. We can, for example, use dot split, for example. Yeah. I'm sorry for that, because the version I'm running now is not the version I have been working on. Yeah, here, as you can see, you get this dictionary in this format, the index here, and here we have the tokens in the beginning. And here we run the same. Here I use just the white space tokenizer. The same, and then I put them together. I merge them according to the index. Here I create a line sentence without alignment, but I will create the alignment now. So for each element I have a line sentence, source and target language, but the alignment, as you can see here, is empty. Okay. Okay, the IBM model, as I said, the word order is ignored for simplicity. So, and therefore, these three examples are the same. So if I have the source and the target in this form, if I change the order of the word, I will get always the same alignment. So it works only, it depends only on the frequency of the words. Here I can import the model from NLTK to translate, import IBM model 1. Then I will train the system only on the first 300 sentences of the Bible, because if I use the whole corpus, it will take 30 minutes, 40 minutes. So just for testing, I will take the first 300 sentences. And here I will repeat, as we saw that we have to repeat the process until we get coverage. Here I decided just to run it for 20 times, and then I get the results here. Okay. Now it's running. Let's see the translation probabilities for the word Geist in German. Geist is translated to spirit with the probability 0.56, to life with the probability 0.37, and to other words with very low probability. For example, if I take Wasser, which is water, yeah, also I get waters, river, yeah, and other words which are relevant. As I said, we are using only the first 300 sentences. When I use more sentences, the accuracy will be better. The word God, yeah, it's translated 0.99 to God. If I want to print the alignment, as I said, here I have am Anfang schuf Gott Himmel und Erde in German, and in English, in the beginning God created the heaven and the earth. Here is the alignment. Anfang is beginning, Erde, earth, Himmel, heaven, God, God, schuf, created, beginning. So here am Anfang, both are translated, aligned to beginning, which for me it looks perfect. The alignment here, the accuracy of this alignment is 100%. Now, if we move to the IBM Model 2, it takes into account also the position of the word, not only the frequency of the word, but also the position of the word. I'm sorry, but the screen is freezing here. I don't know why. Yeah, here the Model 2, as I said, it takes an count how many times a source language word is translated into target language word, and also count how many times a particular position in the source sentence is aligned to a particular position in the target sentence. Now we will run the IBM Model 2 and compare the results. Here it's the same steps. Here it's running now. It takes more time than the IBM Model 1 because here we add more processing steps. Also, I used only the first 300 sentences. Here, if I print the second sentence, and God said, let there be light, and there was light. Yeah. God sprach, said, Licht, light, part light. For me, it looks pretty good. Here we have also the first sentence, which will be the same. Now, if I want to compare the two models and see the differences in the probabilities, here, for example, I will use the word Licht. I will get the alignment in using the Model 2 here, for example, and here in the second one. Let me see Geist, for example, here also, and Geist here. Look at here, Geist is translated 100% to spirit. Here, spirit, Geist is translated to spirit only 0.56. So as you can see, the IBM Model 2 produces more accurate results than the IBM Model 1. Also, I can check it with the word Wasser, which is water. As you can see here, the alignment is 0.55, and here the alignment is 0.41. You can also try with more models, just import IBM Model 3, Model 4, Model 5, and you can see and compare the results. As I said, if you use more sentences or the whole corpus, you will get more accurate results. Yeah, that was the tutorial. I hope you can learn something from this tutorial. We saw how we can create parallel corpus from a text data and how we can align them automatically using IBM models.
Thank you, Tariq. That's really, really interesting to see how that works. I think it'll be interesting to people following this course as well who've seen Python and seen Jupyter Notebooks for the first time 2 or 3 weeks ago, to see another one in action and to be able to go through it. And I think the interesting thing to learn there is that you don't need to know how to code all of this. They can take your notebook and they can change a couple of things and get other results. Will you fix the couple of things that weren't quite working there and re-upload it? Then people can look at it. And so then we suggest that that you maybe give a couple of hours for the new version to appear, and then download this notebook, open it in Anaconda or wherever you're running your notebooks, and change some of those texts. Look at a couple of different language texts if the English and German is not the parallel that's most interesting to you, and just have a go at looking at those alignments, seeing how they work. Try it if you've got a bit of time. Maybe set off doing a corpus of slightly larger than 300 sentences. Set it off before lunch and then come back and see if that improves the model that it's created. I think it'd be interesting to just have people try that out. Yeah. Great, thank you. Does anyone else have any comments or questions or suggestions?
I would like to ask about where on the Yoga site you can see the graphs and even potentially write down these search paths that you showed us.
It's not online yet. We are now developing a new version of Ogarit, and these transition clouds will be available in the new version.
This is something really interesting and really useful also, in addition to all the other features.
Thank you.
Yeah, that was very exciting. Yeah. Anybody else wanted to add anything? Keeping an eye open in case anyone watching live wanted to ask a question in the live chat window, but they haven't yet. Please feel free to do so if you are watching live. But anyone else in the meantime? Or did you have any questions for each other? I know you work together on this, so maybe not. But I think
sorry.
I don't have any immediate questions either. So I think the main thing will be to try that. I'm actually quite keen to download this this notebook and have a go at it, and see if I can understand that I'm replacing the right bits and and actually make it work. So that'd be cool. So one question
about in 2 minutes, 5 minutes.
Lovely, thank you. One quick question about that. Do they need to install NLTK before they can import it?
Yeah, I guess, yeah, of course. Yeah.
Yeah, okay. So that's something you'll have to do either from the command line or...
Yeah, but it's very, very easy to install it on Apple and Ubuntu. On Windows, it's a little bit tricky, but yeah, there are so many tutorials online how to install.
Yeah, they had a bit of exercise of installing a couple of libraries for the first Python class. So if they should be able to go back and Anaconda will help you do that if you're using that anyway. So yeah, cool. Okay, if no one else has any comments or questions, we might thank Chiara and Tariq again. This is extremely clear and extremely exciting session. I thought this was very cool. And just to say to everyone else, please join us again next week so the next session in sequence, it actually is already on YouTube from a couple of days ago. That's the second of the two sessions on tree banking, which will be the next one you will watch if you're watching them in sequence. And the next one we will be here to record live with you will be in 2 weeks today, then, which will be the last session in this semester on text visualization, which will be with Matteo Romanello and Aurélien Berra. So I hope you'll join us for that. Thanks very much, and bye.
Thank you very much.